Hey guys, today we're going to talk about priming the cardiopulmonary bypass circuit over here at USC. So we're just going to go through what it takes to prime a circuit once it has been built and is set up and ready for use. So the first thing we're going to do, actually, kind of counterintuitively, is we're going to hook up the water lines. And the reason we do this before we actually prime the heart-lung machine is we want to make sure that there's no leak from the water side of the heater cooler to the blood side of the heater cooler. So once we get this on and flowing, we can make sure there's no manufacturer defect in here that introduces water into the blood side. So that's the first thing we're going to do, and I'll turn it on. While we're waiting for that to prime up and get flowing, I'm just going to check over the circuit and make sure nothing is loose. Depending on the hospital that you're at, some hospitals will set up the heart-lung machines the day prior. Some you will set up the heart-lung machine before the case. But it's always a good idea to make sure that everything that you are getting into is secure. Nothing has been put on perhaps backwards or incorrectly.
Yeah.
I do. Great, so it looks good. So I'll move on, and as I make sure that my heater cooler is not leaking, which it doesn't look like it is, I'm going to drop my crystalloid fluid into the reservoir. And so to make sure that it doesn't first go to the centrifugal pump, I'm going to clamp down here right at the outlet. And then I'm going to drop in, depending on your system, I'm going to drop in about 1,400 of our crystalloid, which is plasmolate A. I'll take my quick pry line, spike both of these. I'll spike both of these, and you can see that as that fluid drops, it will start to fill up the reservoir. And again, it's not going to go any further because I'm clamped at the outlet. But I'll show you in just a moment how we move that fluid forward. So we'll let that move through. In the heater cooler, like I said, it doesn't look like it is leaking over to the blood side, which is exactly what we want. So I have clamped one of my bags. That 400 has gone in, and I'll let the other run in completely so that I drain in 1 liter through this bag, 400 from this bag, and that will make 1,400 down in my reservoir. Okay, now that this is almost filled with my 1,400 of crystalloid, I will prime the centrifugal cone. And it's going to be a little tricky. I know that we walked through this in SimLab, but the easiest way to go about this is to remember that air rises. And so the last point of air is back here. So as soon as I unclamp this, fluid is going to push forward, and it's going to want to try and remain level with what is in my reservoir. So if I point this up and allow this to open, you can do it in a nice controlled fashion. And again, you can see that it wants to remain level with what's in the reservoir. As I start to dip it down, the fluid level increases, and I'm going to very strategically walk the surface of this water level, or crystalloid level, up and out in such a way that there should be no residual air. There's a teeny bubble. You can bang it a little bit and make sure that there's no air lingering. Looks pretty good. And put it back in its housing. Once it's back in its housing, once it's back in its housing, we can turn it on and start to flow forward. So now that my centrifugal cone is primed and fluid is pushed forward into the oxygenator, I can come over here and turn on my pump, and you'll see that this starts to control and starts to spin the pump. The fluid level is now rising. If I look at my AV loop, I can push forward a little harder. And it doesn't take a whole lot. I'm at about 800 RPM right now, which would not be enough on a patient, but since we don't have very much resistance, it's enough to start to push through our circuit. Turn it up even higher. So I'm now at 1900 RPM. You can see that my fluid is pushing through the loop and it's coming back. And some people like to go a little faster, give this a couple smacks to get rid of any lingering air. Usually it's pretty good not having any air bubbles, but we want to make sure that it's completely air free. So I'll just put this up for the time being. So it's a little hard to tell, but right now most of our flow is actually being diverted through this recirculation line. So before we continue priming, we're going to have to close this, and you might be able to notice that now a whole bunch of the flow is going to be going through the loop instead. Now that we're recirculating through our AV loop, we can go through and work on our ancillary components. So we have our manifold. We can see that there's crystalloid flowing through the manifold. We can see that the oxygenator purge line as well is flowing crystalloid through it. So now I'm going to open up my hemoconcentrator, let some crystalloid flow through this, and this does not need to be completely air-free because remember it drains into the reservoir, which does the defoaming and the air removal. So anything going to the patient obviously needs to be air-free, but if it's going back to the reservoir, you can afford a few bubbles. So I have our hemoconcentrator primed. Next, I'm going to prime my pressure dome. I know we walked through this as well in SimLab. It helps if you have a little bit of pressure on your arterial line. But we'll walk through the air. Remember, big bubbles eat little bubbles. Bring that up. And we want the membrane of the pressure dome on this side slightly so that it has a lot of room to create a positive pressure when we are on bypass. And I'll hook that up to the red one. Let me show you that. You can see on this setup we have our different pressures labeled. So arterial pressure is going to be red, cardioplegia is yellow, and vacuum assisted venous drainage will be blue, which correlate with the 3 positions of pressure domes here. So anytime you have an arterial line, if you hook it up to here, it will correlate with this one right here. I can turn it on and open right now. Have a forward flow, and you can see my circuit, my arterial line is experiencing a pressure. And when I set up my cardioplegia, I'll put it on the yellow. If I use vacuum, I'll put it on the blue. And what's actually good practice to do is to zero your pressures at any point before your case. So the way that we're going to do that is we're going to open this up to air, and it's going to spurt out just a little bit. But when we open this up to air, if we come over here, we can see that it's reading -5. So it's close to 0, but in order to make sure that when it experiences the atmosphere, it is truly measuring at 0, we can click on the pressure, we can zero it, and now you'll see that that jumps to 0, and what we see here will be a little bit more accurate of a reading. Remember that we need to close this in order for this pressure to be reading, and we can put a cap on there so that it is sterile and secure. So that is good there. You can see we're reading a pressure right there. Now is a good time as well to put on the effluent line to your hemoconcentrator. So I just got a suction line, and I will put it on the hemoconcentrator here like this, and make sure that it goes to a suction canister over here so that when we hemoconcentrate, the effluent fluid, the waste fluid that we're filtering through, has somewhere to go. Okay? Next, we're going to prime the cardioplegia circuit. So even though we're flowing through with crystalloid all through our circuit, this still has air. I have set this to be occlusive, meaning that it is in the roller, so fluid has not been pushing forward, meaning that the tubing has been loaded into the roller, and the roller is keeping any of the fluid from moving forward. And so usually what we do when we set up pumps is we set it out of the housing here like this, and this keeps the tubing from getting kinked where the roller makes contact, and it will form a memory, which is not what we want. So before I started this video, I just loaded this in here, and that has kept my fluid interface here from moving forward at all. So a good way to check your occlusion actually of your cardioplegia circuit is to find where your fluid level is. So I'm right there, and I'm going to loosen up my occlusion until it starts to move. So you can see I'm just clicking it loose, and you can see right there I have fluid moving through. You can see on this side it's continuing to move through, and I'm going to move it tighter until it decides to stop moving through. And once it's stopped moving through, that I can be sure I'm occlusive and I'm compressing that tubing. There's no fluid moving forwards. So this will not let you turn on the pump if the lid is open. If I open the lid, it will tell me lid open and I can't control it. And another thing that's a little tricky is that you have to either select a volume of a dose for cardioplegia or tell it that you're flushing. If you don't do either of those, you're not going to be able to control the pump. So I'm going to tell it that I'm flushing, don't record this dose. As I spin forward, and you can see the fluid is moving through. It doesn't need to be at too aggressive of a speed, but as we see it start to move up through our cardioplegia component, move it a little faster. You can see it's moving up, our cardioplegia component, and as it comes up, let me fix this. You can see that it's moving up and priming this cardioplegia component. And as it starts to prime it fully, you can see it will fill the bubble chamber, which is this right here. It will capture any bubbles, and it will start to come to the delivery line. You can just clamp that and wait to hand that up to the field when we're ready. I'm still flowing forward, which I'm going to have to open my pressure dome so that as I flow forward, that fluid has somewhere to go. Now we can see it's coming through, and I'll turn it off, and I'll turn the pump off. So now I can hook this up right onto the yellow one because that is what the cardioplegia pressure is reading. And keep in mind, if you're not seeing a pressure when this is on, it's probably because you're not in this position to read. Okay, just a few more things. Next we're going to check the occlusion of our suckers. So we can do this, we should do this on all, both the vents and the suckers. I know we went over how this is done, but the easiest way is to clamp the inlet all the way, turn it on, and make it occlusive until it starts to snap. So here you can hear that, so here, if you listen closely, you can hear the snapping that happens. You can see that the tubing becomes compressed as it creates that suction since we're clamped up here. If I come a little looser, this will start to loosen up right there. So you can see that it was flat and it opened up. That is just where we are under occlusive, so I turn it up 2 more clicks and that should be good. And I will do this for all 3. My sucker, which is my yellow, my aortic root vent, which is blue, and what will be my LV vent, which is red. So we have a good number of safety devices that we need to use for perfusion, and now is a good time to put them all on. So first, we have our level sensors. These will tell us if our level in our reservoir goes down a little too low. Our yellow is the alert, and the red is the a little bit more severe alarm. So you can see that when these are in contact with fluid, the light stays on. If there's no fluid behind what they're in contact with, then they go off to the light off position. So I'm just going to take a piece of double-sided tape. Oops, it stayed on here. Put the double-sided tape there, and you want your yellow to be a little bit higher than your red, since your yellow is your alert, which will go off sooner. Red is like your last resort, so we never want to go below wherever red is at. Next, we have our temperature probes. We have this one is the venous probe. So I'm just gonna put this in and twist. And then we have our arterial probe. I will try and keep this as not twisted all around as possible. But the red, as well as goes with the outlet of the oxygenator, this temperature tells us what the temperature of the blood that is going to the patient will be. Again, we don't want that to be too hot, but that will tell us what that temperature is. Next, we have our Spectrum. Spectrum is who makes our heart-lung machines and all of our analysis devices that we use. These look at the blood through the tubing and tell us the content of the blood. So they tell us the hematocrit, the VO2, the saturation. You'll get more into that as your clinicals continue. But the one with the red, intuitively, is the arterial. Arterial is typically red, so we'll put that on the arterial line. It can be anywhere after the oxygenator. Blue is venous, obviously. Blue is typically venous, and this will go on our venous line. Again, this can go at any point on the venous line that is sterile and not too far to reach. Finally, we have our flow probes. AF will indicate arterial flow. So this is a little bit tricky because we don't want this to go before, we don't want this to go distal, upstream of things like our hemoconcentrator, because this may be reading 4 liters per minute, but that's not taking into account that we're bifurcating and our flow is diverting, and maybe 1 of those 4 liters is going to the hemoconcentrator while only 3 is going to the patient. So in order to really have a true value of the flow that's going to the patient, the arterial flow probe should be as distal or downstream as we can put it. So I'm just putting it up here. You can see that there's nothing between this part and the patient, so that is going to be a true reading of what the flow going to the patient is. We use a flow probe as our bubble detector. Make sure that when you put these on, the arrows go in the correct direction of flow. So I'm going to put this on because flow comes out that way. If you have it in reverse, it will measure a negative flow, which obviously is not right. So we'll make sure that it's going in the correct direction. Venous flow detector. So I'll put this on the venous side. Up here like this. As you can see, we're measuring both arterial flow and venous flow. And the reason these aren't the same is because we have what we call shunts, which, looking back at this, some of our flow is going through our manifold, some of it is going through our oxygenator purge. Next, we're going to check our oxygenator. So I'm going to turn on our sweep and our FiO2, as well as our anesthetic gas. And I'm going to make sure that there is indeed gas going into the oxygenator. So I can do that either by obscuring and making sure that there's a positive pressure. I can hold it up to my ear and know that I feel gas coming forward. And then I also want to make sure that my outlet is free and clear. In this case, we have waste anesthetic gas that we put onto the outlet. Finally, we can take out the pre-bypass filter. To do that, we would just take a clamp, making sure this stays above the floor. Finally, we're going to take out our pre-bypass filter. So to do that, I'm just going to take our venous line, and we're actually going to take out this segment of tubing as well as the pre-bypass filter. So if I just clamp, and I can do this because we're using a centrifugal pump, a non-adhesive pump. So I'm stopping the flow, and I'm going to, again, I'm just going to let this drain. It's draining into the reservoir right now. And then I'm going to take off this piece of tubing. I kept this sterile down here, so now I can put this back together, nice and tight. And now that is ready to go. Now before we are done, you just want to make sure that everything is on tight. There's no air in any place, especially like the oxygenator, or any air hanging on to any connectors or anything. You can just tap it out if you do see that. And you want to make sure that you have your last safety devices, which only should be required in emergencies: your oxygen tank, if your oxygenator fails, or your sweep gas ventilation system fails for whatever reason, have an oxygen tank, make sure it's full, and then have a hand crank in case something happens with your pump, either your rollers or your centrifugal. You want to be able to pump that by hand. And now you are ready to adjust your bypass circuit. You have primed it and it is ready for use.